Can you add and subtract mixed numbers? We are going to explore this with the help of 9 examples. Do we really need to convert them to improper fractions? That also will be answered. Let us enjoy this journey of learning and understand everything about mixed numbers. Three different examples illustrating you all the three cases which you get when you're talking about unlike denominators. Correct. So we are adding mixed numbers with unlike denominators. So I hope you find this useful. So let's begin with the very first one with Anil Kumar. I'm Anil Kumar and welcome to my YouTube channel. Absolutely free for the last 15 years. You can post questions and get the solutions within 48 hours. Great. So now let's see how do we answer this particular question, that is adding improper mixed numbers without converting to improper fraction, right? That's the beauty. So we need to do 4 1/3 plus 2 1/6. You see, 4 and 2 are proper numbers which can be straight away added. So think like this. So we have 4 and 2, we can add them up, right? And then we'll add 1/3 and 1/6. Makes sense, right? So 4 plus 2 is equal to 6, right? So we have 6 plus 1/3 plus 1/6. Do you see how we have just added the numbers and now we are going to add the fractions? That is what is mixed number, right? Now, 1/3 and 1/6, we have to look for a common denominator, which is of course 6, because 6 is a multiple of 3. So we have 6 plus, we have to convert 3 and 6 into 6, right? So how do we do so? Well, for 3, 1/3, we have to write times 2, right? So it is 2 over 6. But the other one is already 6th, right? So we now get 6 plus 2 plus 1 is 3, right? So 3 over 6. 3 over 6 you can simplify and make it half. So it becomes 6 and a half. Do you see how easily we have done, right? So important here is that this could be reduced to half, right? Dividing by 3. You get the whole idea. And we get our answer. So I hope this step is absolutely clear. Perfect? Well, if you like my videos, you can subscribe to them and also write your comments if you need help with any question. Now let's move on and take the solution of the next question, which is 1 2 over 7 plus 2 1 over 3. Remember, whole numbers we could add directly, right? That is the strategy. So we'll first write like 1 plus 2, we'll add them up, and we are adding the fractions separately. So we are not really converting them to improper fractions. We are working with numbers which are lesser, right? So 1 plus 2 is 3. Now here, how do we add these fractions? Which you know, right? Common denominator. Since 3 and 7 are co-prime, we can cross multiply, right? So common denominator will be 3 times 7, 21, and 3 times 2, 6 will be the numerator. Here we'll multiply by 7 and we get this as our result. Now clearly, what is this equal to? It is 3 plus 7 plus 6, right? 7 plus 6 is 13 over 21. And that can be written as 3 13 over 21. Do you see how simple it is? All numbers are as they were, simple. We did not complicate them, we did not make them bigger and larger. No conversion to improper fraction. So that's the beauty. So you can apply this strategy to the last question. Let's do it together. So we have now 2 3 over 4, to which we will add 5 and a half. So first step, add 2 and 5, correct? And then second step, add 3 fourths with half. 2 and 5, is 7, and 3 fourths and half. Okay, so convert them to 4, right? Which is 2 over 4. Correct. Now clearly we have 7, 3 plus 2 is 5, right? So 5 over 4. Now you see 5 over 4 is an improper fraction. Means 1 over 4, right? So we can write this as 7 plus 1 over 4, right? Now we can combine 7 with 1, so we get 8 1 over 4 as our answer. So if there is carry forward like it is in this particular case, you see how easily it can be handled. So with addition, it is not a problem at all. With subtraction, when we have to borrow, then it becomes difficult sometimes. Correct. So I hope with this you have understood the method. How do we add mixed numbers with unlike denominators? And that too without converting to improper fractions. That means working with small numbers. So less errors, excellent method, much faster, as you can see for yourself. I hope it makes sense. Let us understand how do we add numbers with unlike denominators. Well, these are mixed numbers. We have three examples before you, and these examples are kind of typical as they will teach you different ways of dealing with such questions. And with that, you will actually master the strategy. As you can see in the very first example, we have 5 and 4 in the denominator. They have nothing in common. So in this case, to take a common denominator, we really cross multiply. The second one is 4 and 6, which do have 2 as a common factor. So here, the lowest common denominator is not 6 times 4, it is 12. You get the whole idea. And in the third case, the denominator is 5 and 10, so we don't have to multiply or do something else. 10, as you know, is a multiple of 5, and therefore the common denominator should be 10. So that gives you straight strategy of solving such questions so fast. So I hope you are getting to know some of the best strategies to answer the questions. So let's go with it. I'm Anil Kumar. Welcome to my YouTube channel. This is where you learn correct ways of doing things. It is also a learning platform, absolutely free for the last 15 years. Feel free to share your questions and you will see the solutions within 48 hours. Great. Now, let's see. How do we add the mixed numbers? Let's begin with the very first one, which is 1, 2 over 5 plus 2, 1 over 4. Now, in this particular video, I'm taking a strategy where we are focusing on converting to improper fractions. Now, in the other video, we will do it without converting to improper fractions, which is slightly faster, right? But we should understand both these strategies. Great. So let's first convert to improper fractions. So now this can be written as 1 times 5 plus 2, which is 7 over 5. 4 times 2, 8 plus 1, 9 over 4. So whenever you're working with mixed numbers, this is the first exercise. So I hope you're very familiar with this. Basically, multiply 1 with the denominator 5 and then add 2. You get 7. 4 times 2, 8 and 1, 9. Correct. Now you see the denominators are different and they have nothing in common. We say 5 and 4 are co-prime. Between these two, there's nothing common. 4 is not a prime number, but it is prime with respect to 5. With 5, it does not have any prime number, so we call them co-prime. So in this case, we can cross multiply. So you can multiply 5 and 4 to get a denominator here, which in this case is going to be 20. Now to make 7 and 4 into 20, we have to multiply by 4, correct? So 4 times 7, 28. And here we have to multiply by 5, which is 45. Makes sense. So basically, what you're seeing is that we are cross multiplying, correct? That is what it is. And the denominator was written as 5 times 4. So that becomes a very neat picture to visualize and follow the steps, right? Now the answer is simple. Let's add 28 and 45. 8 plus 5 is 33, 1, 5 and 2, 7, over 20. Now we need to convert it back to the mixed numbers. 20, 20, 20 means 60. So it goes 3 times and 13 is left. That's how it is. And we get 13 over 20 as a final answer. Perfect. I hope all the steps are absolutely clear. Perfect. Feel free to subscribe to my videos, and you can also send an email to globalmathinstitute@gmail.com to learn more. Great. Now let's take up the next question. The next question here is 2, 1 over 4 plus 3, 1 over 6. So let's first convert it to improper fraction. 4 times 2, 8, and 1, 9 over 4 plus 6, 3, 18, and 1, 19 over 6. So between 4 and 6, what is the LCM? So we have to find the LCM first. So one technique which is very easy to use is division. This is a special division. So we can divide both by 2, right? And so we get 2 times 3 times 2, which is 6 and 2, 12. That is our LCM, right? So to make it 12, I have to multiply these by 2 and this by 3, correct? And let's rewrite. Correct. So this is equal to 3 times 9, which is 27, over 12, plus 19 times 2, which is 38, over 12, right? Now we can add them up. So with the denominator of 12, we get 8 plus 7 as 15, and 3 plus 2 plus 1 is 6. 12 times 5 is what? 12 times 5 is 60. So 5 wholes and 5 over 12. So that becomes our answer. Correct. So that is how we will do it. And you can see we could have done without converting to improper fractions by adding 3 and 2, which you get 5, right? And then 1 over 4 plus 1 over 6 will give you 5 over 12. Okay? So you can see how we could have done it without converting, but we are going to get into that in the next video. It has its limitations though, right? But this is a very general way of doing it. So it is preferred way of doing. Great. Now let's take up the last example here. We need to now add 2 7 over 10 plus 3 4 over 5, right? So first step, convert to improper fractions. So we could rewrite this as 2 times 10, 20, and 7. 27 over 10 plus 15 plus 4, 19 over 5. Now we have to take the LCM, right? So LCM in this case is 10, right? 10 is a multiple of 5, so you don't have to think much. So how do you make 10? Well, for the first one, it is already there. And for the second one, multiply by 2. So we have 38 over 10. Add them up. 3 plus 2 is 5. 8 plus 7 is 15. 15 and 1 carry. So 65 over 10. Right. That means 6 whole. And what are we left with? 5 over 10. We could reduce this and write this as 6.5, right? So now we have seen how do we add mixed numbers. Now here is example of how do we subtract them. Let's understand the strategy with the help of three more examples. How do we subtract mixed numbers with unlike denominators? We are going to discuss the best strategy with the help of three examples. As you can see, we are going to do 3.5 minus 2 1/3, 5 1 over 4 minus 2 1 over 6, and C is 3 7 over 10 minus 1 4 over 5. Not only they have unlike denominators, but there is a variation. You will see that denominators may have a common factor, they may not have a common factor, and sometimes when you subtract, you may have to borrow. So there are different strategies which will be applied to solve all the three questions. So stay with us to understand all the strategies once for all. I am Anil Kumar. Welcome to my YouTube channel. Absolutely free for the last 15 years, a platform where you can share the questions and get my solutions. So now let's begin with the very first question here, which is we need to understand how do we subtract improper numbers when the denominators are not the same. So we have 3.5 minus 2 1/3. Now this type of question can be solved very easily by not converting to improper fractions. However, we'll follow one strategy where we will be converting to improper fractions in general, right? So the first step will be to convert to improper fraction. How do we do that? 3 times 2 is 6 and 1 gives us 7. So you multiply 3 with 2, right? And then add 1. Keep the denominator as it is, right? Similarly, it is 2 times 3 plus 1 and the denominator remains as 3. So we get 6 plus 1 as 7 over 2 minus 2 and 3, 6 plus 1, 7 over 3. Is that clear to you? Correct? So these are all equivalent expressions. Now you see that the denominators are not the same. 2 and 3 are both co-prime. They do not have anything in common. So in this case, we can actually cross multiply or make the common denominator as 6, 3 times 2, right? So making it 6 means that I have to multiply 7 and 2 by 3. So 3 times 7 is 21 minus. To make this as 6, I have to multiply twice, right? So it becomes 14. So you see, we get 21 over 14. 21 minus 14 over 6, right? So I'm going to rewrite this as equal to, in the numerator, we have 21, from where we have to take away 14, and the common denominator is 6 for us. Is that clear to you? Now 21 minus 14 is 7 and 7 over 6. So what do we get? We get improper fraction which now we can convert back to mixed number. Dividing 7 by 6 we get 1, 1 remainder and 6. So these are the steps which we are going to follow, right? There was a simpler way, of course, which is 3 minus 2 will give us 1, and then we could do half minus 1 over 3, right? So in this particular case, that could have been better. However, Understanding one's strategy clearly and performing consistently is better. Okay, great. So we got the very first one. I hope you have understood the strategy, correct? Follow this process and do the other two. Now, let's take the next example, which is B. And this time we are going to do 5 1 over 4 and we'll subtract 2 1 over 6. Now, common denominator does not necessarily mean that you multiply the denominators. If you do so, in this case, you get 4 times 6, 24. However, they have something common which is 2. So the common denominator is not 24. I mean, the lowest common, right? So the idea here is always to find the lowest common multiple. Now, between 4 and 6, it is 12, which is lowest common multiple. You will also use this ladder kind of a division method, which can help you to factor out the common factors. For example, here we could divide by 2, correct? And therefore, we have the LCM as 2 times 2 times 3, which is 4 times 3 is 12. So we have to make the common denominator as 12, correct? But before that, we will again convert this to improper fractions. So let's do the conversion. So this time I'll do straight 5 times 4, 20 plus 1, 21. So you know now 21 by 4 minus 6 times 2, 12 and 1, 13 by 6. We need a common denominator of 12. So I'm going to multiply 21 by 3, right? So that gives me 63 by 12. And here, multiplying by 2 will give me 12 in the denominator. So numerator also will be twice, 26. Now we get our answer, which is what? We'll take away, so let me just do it on the right side. I might need more space. Correct. Okay, great. So we'll take it here. So what we have is a common denominator of 12. We can now do 63 minus 26. Clear. So 13 take away 6 is 7, borrow 1. So 5 minus 2 is 3. So we get 37 over 12. Now back to the mixed numbers. 37 times, we'll go 12 times 3 is 36. So we are left with 1. And so that will be 3, 1 over 12. Is that clear to you? So what we did was, we divided 37 by 12, right? So 12 times 3 is 36, and the remainder was 1. That is how we got our answer, right? So this is the remainder still to be divided by 2, and that is the quotient 3, right? So I hope you have understood here that LCM does not really mean that you just multiply the denominators, right? So, well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top since they use the best strategies to solve problems. Great. Let's now look into the third question here, which is 3 7 over 10 minus 1 4 over 5. Now, in this case, 10 is a multiple of 5. So we don't have to do much. We know that we need to convert it to LCM of 10, right? Correct. Well, the first step will be convert that to improper fraction. 3 times 10, 30 plus 7, 37 over 10 minus 5 plus 4, 9 over 5. Correct. Let's convert 37 over 10 minus times 2, right? 18 over 10. Great. Now here we can do 10 is the common denominator. I prefer to write together like this. And 37 you could write separately also as it is already written. Correct. So 37 minus 18, right? So So 17 minus 8 will be 9, and 2 minus 1 is 1. So we get 10 in the denominator, 19 in the numerator. So it is 1, 9 over 10. Makes sense, correct? So that is how we are going to do subtraction of mixed numbers with unlike denominator. So I hope you have understood this strategy. Go through our playlist and see how do we work efficiently with fractions and many other questions. If you like and subscribe to my video, that'd be great. Thanks for your valuable time and all the best.